In this video, we're going to talk about random variable and normal distribution. Now, random variable is from chapter 5. So we're going to only look at the concept of random variable from chapter 5. We're not going to look at anything else. And chapter 6, there are 3 different probability distributions that are covered, and we are going to look at only the normal distribution. Now, what is a random variable? Random variable is a numerical description of an outcome of an experiment. Well, that's a technical definition. Random variable is the value of a variable that cannot be predicted in advance, but what the possibilities are, we can enumerate them. For example, if you say you're going to roll a dice and then observe what number you're going to get. So when you roll a dice or a die, you don't know which face is going to come up, but we know that it is going to be a number between 1 and 6, the integer value. Okay. We know what the possible values are, but we don't know what the actual value will be. Another example, suppose we have sales. Okay. What is going to be the sales for the next 1 week? Okay. We can say that it can be at least 100 units and all the way up to 900 units and any number in between. But what will it actually be next week? Well, we can only tell what the possibilities are, but we don't know what exactly will happen. So that's what random variables are about. You can tell what the possibilities are, but we cannot tell what will actually happen in the next instance. Now, if the possibilities are discrete, okay, remember we talked about discrete numbers, discrete variables in chapter 1. So if you have a discrete set of possible values for the random variable, then we have a discrete random variable. The example would be how many customers will be arriving in your store in 1 day. So it can be no customers at all, or 1, or 2, or 3, and so on. So you have specific numbers that are countable. So when you're able to count, and that is discrete. So we have discrete random variable. Now if a variable takes continuous values, then it is a continuous random variable. So like an example would be, what is the time between successive customer arrivals? You can only tell that it's a number greater than or equal to 0, but you cannot tell after 0 is it going to be a particular number. We cannot tell that. So it is a continuous. You cannot count what the possibilities are. You can only say what the range of values will be, but you cannot count them. In that case, the variable is said to be a continuous random variable. Now, chapter 5 talks about discrete random variables in more detail. Now, chapter 6 is about continuous random variables and the probabilities associated with continuous random variables, of which normal distribution is what we're going to talk about. Some examples of discrete random variable would be like binomial distribution, Poisson distribution, and so on. In continuous distribution, examples would be uniform distribution, exponential distribution, and of course normal distribution. So we'll talk about normal distribution in the next video. In this video, we're going to talk about normal distribution or normal probability distribution. And this is the theoretical function for normal distribution. And if you put x on the x-axis and compute the f of x on the y-axis and plot those values, this is what you will see. Now this curve is symmetric. Okay, there is no skewness. So if you look at the center, the left side is a mirror image of the right side. So that's why it's called symmetric. Now the entire family of normal probability distributions can be defined by defining 2 values, the mean mu and the standard deviation. The mean varies, the curve will shift left and right. If the standard deviation varies, it will become tighter and wider. Now the highest point is also the center point and also the mean. In other words, normal distribution has this special property of the mean, median, and the mode all falling on exactly the same point. Now the mean can be negative can be 0 or it can be positive for a normal distribution. The standard deviation has to be greater than 0, and the smaller the standard deviation, the more tighter the curve will become. The larger the standard deviation, more spread out and flat will be the curve. Now, the probabilities of normal distribution are given by the area under the curve. So if you look at the area under the curve on the left side and the area under the curve on the right side of the center, those two values will be equal, and since the total area should be equal to 1, so it will be 0.5 and 0.5. If you want probability for any given range of x values, then you have to look at that range and what is the area within that range. And for all continuous probability distributions, including normal distribution, the probability that x is equal to exactly one particular point is 0, because the area for that line, the area of a straight line, is 0. So you have to have a non-zero interval, then you will have area under the curve, and that will be the probability. And if you want probability that x is equal to a specific value for normal distribution, then you don't have to do any computation, it is 0. Now the empirical rule is if you go from the mean 1 standard deviation, you get about 68.26% of all values falling. If you go 2 standard deviations, it will be 95.44. If you go 3 standard deviations, that will be 99.72%. Now a random variable with normal distribution with mean equal to 0 and standard deviation equal to 1, that particular normal distribution is called standard normal probability distribution as opposed to any general normal distribution. For the standard normal distribution, we use the letter Z instead of the regular X. So Z is reserved for standard normal. So if you see Z, then you should think of standard normal distribution, mu equal to 0, sigma is equal to 1. So you can convert any normal distribution into a standard normal distribution by using this formula x minus mu over sigma. So this will tell you how many standard deviations x is from the mean mu. So this is standard normal, or this is the formula that is used to compute Z, and then you look up the probability from the normal distribution table. But we're going to be using the Excel functions to find normal probabilities, and that is covered in the Excel tutorial videos.